Friends, welcome to this channel Dr.ARM's Chemistry. So last time we have seen the complexes of metal carbonyls with isocyanide. Now we will see the next point, that is complexes of metal carbonyls using these dinitrogen ligand. So these are called dinitrogen complexes. Here this nitrogen is as N2, that is dinitrogen. So this will have a triple bond structure like this, dinitrogen. If we see the complex, this dinitrogen, that is N2, it is isoelectronic with this carbon monoxide. Is the number of electrons involved in this bond formation, that is carbon monoxide system and N2 system, are the same. So they are called isoelectronic. And because of this, it is speculated that since we have obtained the metal carbonyls, it is also speculated that we can obtain the dinitrogen complexes easily. Then here if we see the metal nitrogen bond, metal nitrogen bond, and if we compare this with metal carbon monoxide bond, so we can see that since the formation of metal carbonyl bond is possible, the formation of metal nitrogen bond is also possible. So if we see the history of these dinitrogen complexes, it shows that in 1965, the first complex of dinitrogen was reported, and it is of ruthenium, that is Ru NH3 5 N2 Cl2. So this was the first dinitrogen complex reported in 1965. After considering the subsequent work on this formation of dinitrogen complexes, it was observed that such dinitrogen complexes can be prepared by 4 different ways, by following number of ways. We will just mention, we will see the methods by which. So this is first by reaction of N2H4 with aqueous RuCl3. Another reaction by which we can prepare this complex is by reaction of sodium azide NaN3 with Ru NH3 5 H2O 3 plus. Third reaction by which we can prepare is by direct reaction, of N2 with this ruthenium complex Ru NH3 5 H2O 2 plus, and one more reaction by which we can prepare is by reaction of RuCl3 aqueous RuCl3 with zinc in ammonia NH3 aqueous. So these are some of the examples by which we can prepare the complex, that is ruthenium complex RuNH3 5 Cl2. Out of these complexes, out of these reactions, so this reaction in which nitrogen is directly reacted with this complex to obtain the ruthenium dinitrogen complex. Here nitrogen is used to displace water. Nitrogen is used to displace this water directly, and this is the most notable point to be noted here. So despite number of such reactions and study, it is found that no effective way is available, or it was available, for the reduction of nitrogen into ammonia. So by that time, until today we can see, there was no direct way to convert this nitrogen into ammonia. But later on, the systems were developed. To convert this nitrogen into ammonia or N2NH4 by catalysis using metal compounds in low oxidation state. So by using metal compounds, generally we say metal compounds, this low valent metal compounds are used to convert this nitrogen into ammonia or N2H4. So this transition takes place via Mn2 complex, via transient Mn2 complex. Here another thing is to be noted that N2 group can be a bridging group of M, N, and M type. So this is the type of bridging group. Here M2 acts as a bridging ligand. So this can be formed using the following reaction. We can consider the reaction like this: Ru NH3 Cl2 plus. So this after reduction in using zinc Hg and nitrogen, so we can obtain from this Ru NH3 twice into 4 plus. So here you will find that this nitrogen is a bridging group between the two metal ions. A terminal type of nitrogen ligand has characterized from IR spectroscopy, where it shows IR absorption in the range between 1930 to 22. IR range is 1930 to 2230 per centimeter, whereas the IR range for nitrogen is IR range. So this range is for this nitrogen which is bonded to mate. But if you see the range for only nitrogen, it is IR range is 2331 per centimeter. So if we see the difference, you will find that the difference is about 100 to 400 per centimeter. The formation of nitrogen complex by direct conversion, by direct uptake of nitrogen at 1 atmosphere have been observed, especially using the triphenylphosphine ligands. Formation of nitrogen complexes by direct uptake of N2 gas at 1 atmosphere pressure has been observed using PPH3 ligands. So we can see it in the form of reactions. So first reaction, COAC C3 triacetylacetone to cobalt. It reacts with 3 PPH3 triphenylphosphine and nitrogen. Here the reducing agent is aluminium isobutyl C4H9 3. So it gives the complex N2 and PPH3 thrice. Another reaction is FeCl2 plus thrice ethyl diphenylphosphine plus N2 in presence of reducing agent as NaBH4 in ethanol. So it gives the complex FeH2N2, then PET-PH2 thrice, ethyl diphenylphosphine. Third reaction is MOCl4. Here PPH2 PPH Me2 dimethyl phenyl phosphate plus N2 plus twice PPH Me2. So this is the reaction is carried out by using sodium NaHg in THF. It gives the cis complex of molybdenum MO into PPH Me2 PPH Me2 whole. So these are some reactions in which we find that the dinitrogen complexes are prepared by using variety of reducing agents where we have used nitrogen gas directly. So this is important. Here we have made direct uptake of nitrogen gas using variety of reducing agents. Here some of the special typical compounds containing metal nitrogen groups have been structurally characterized. The variety of dinitrogen complexes were structurally characterized, and it is found that the 3-atom chain, so you will see here metal, nitrogen, nitrogen. So this is a 3-atom chain. So this chain is linear. So here the nitrogen distance in this complex, this nitrogen distance is longer, whereas this metal nitrogen distance is shorter. This is because the electrons of this is because the electrons, sigma electrons, are shared with this metal, and as a result of this the bond is weakened and this bond is strengthened. So the bond is shorter, metal nitrogen bond is shorter, whereas nitrogen bond becomes weaker. Then it is also observed that this shortening of metal nitrogen bond indicates that there is evidence for the formation of pi characters or pi bonds. So the shortening of bond, metal nitrogen bond, indicates evidences for multiple bonds. The bonding in M and 2 group is similar to that AMCO group. This M and 2 bonding is similar to M carbon monoxide group. The same basic components, that is same basic components in this case, that is the nitrogen is sharing its sigma electrons with metal. Similarly, this metal shares back its pi electrons to nitrogen. So here nitrogen is pi accepting ligand. Here nitrogen is sigma donating ligand. So these components are evidence from this variety of study of characteristics of the metal nitrogen compounds. The major quantitative difference between the metal nitrogen compounds and metal carbonyl compounds is due to the slight difference in molecular orbitals of nitrogen and molecular orbitals of carbon monoxide. Means energies of molecular orbitals of nitrogen slightly varies with that, means energies of molecular orbitals of carbon monoxide, and that is why this N2 bond means N2 is weaker ligand than this carbon monoxide ligand. As a result of this, the stability of metal nitrogen compound is comparatively less than that of the metal carbonyl compounds. So this is about the metal nitrogen compounds. So we will stop our discussion here. Please do subscribe to our channel. Also place the like button, press the like button, and also